Okay, so here's the thing. Looking at page 21, go to page 21. Make sure you have a calculator and that you have your colors blue, yellow, green. You need all three. And I guess if you don't have a calculator in your three colors, you can pause the video while everyone goes and gets those things. So looking at page 21, here's the thing. We, so far, have done some calculations where we only had to do two fractions, and we could travel between grams and moles, or between moles and atoms. And we were doing this coloring thing that kind of helps us visualize stuff. But it turns out there's a more deliberate reason for the colors that we're using. And I want to discuss that reason by drawing what we call a mole map. So we know that grams can be related to 1 mole. And we know that 1 mole can also be related to atoms. We know that when it comes to grams, we were using a number from the periodic table. And we know that when we were using atoms, we use 6.02 times 10 to the 23rd. And the kind of memory trick we use for that is knowing that atoms are blue, and when it's blue, you use 6.02. It rhymes. When it's blue, use 6.02 times 10 to the 23rd. We also know that grams are yellow, golden grams, like on the periodic table. And here's where I blow up some of your minds. What do you do? What do you get when you have yellow and blue and they mix together? Dun, 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 dun. Oh my goodness. In the middle you get green. Between blue and yellow, you get green. Look at that. Look at that majesty. And you know what's between blue atoms and yellow grams? Green moles. There's a method to the madness. There is a reason that grams have to be yellow, atoms have to be blue, and moles have to be green. And that's because you can never have grams and atoms together. You always need moles in the middle. Moles in the middle, always. Moles in middle both start with M. You always need moles in the middle. That's another dumb little memory trick. Golden grams, when it's blue, use 6.02, and moles in the middle. Because yellow and blue can never touch, they just turn into green. Yellow and blue can never touch, you always have green in the middle. You always have green in the middle. You always have moles in the middle. And if we look back at some of the shortcuts we wrote on page 18, we kind of wrote this down and just hadn't used it yet. That if you have a two-color fraction, one color is always green, because blue and yellow can never go together. Because if you try to put blue and yellow together, you just end up with green. And that's important because we now are going to try some problems that involve 3 fractions instead of 2. And here's how you'll know if they involve 3 fractions. Let's look at this example. It says in chemistry class, the student was using 189.2 grams of sodium. How many atoms were used up? And if we go color that, we know that grams has to be yellow, golden grams. We know that atoms are blue. And if you're ever using yellow and blue together, you have to have moles in the middle. You can't have just yellow and blue. You have to have moles. You can't ever use just yellow and blue. You also need green. You can't ever use just grams and atoms. You also need moles. The only way you can get from grams to atoms is if you have moles in the middle. And that means if you don't see moles in the problem, I would write this down. If you don't see moles in the problem, they secretly go in the middle. Meaning you need 3 fractions. Ultimately, 1 per color. You need a fraction for yellow, a fraction for blue, and you need a fraction for green in the middle. Otherwise, our steps are pretty much the same as what we did with the 2 fractions. You still take whatever they gave you, a number, a unit, and an element. You rewrite that number, unit, element over 1. I would like to point out that sodium on the periodic table is not S, it's Na. And we still color it. But when I've got yellow and blue, I actually need yellow and green and blue. I can't go straight from yellow to blue. I've got to go from yellow to green first, and then from green to blue. Which means I need 3 fractions. So I'm going to draw all 3. Remember, we've already drawn 1. Here's fraction 2, here's fraction 3. Just like before, whatever they're asking us to find is still going to go on top of the last fraction. So they're asking us for atoms. That's still going to be the last fraction is atoms on top. Whatever they're asking for goes at the very end on top. And we're still talking about sodium in this whole problem, so I'm going to label it sodium. And I'm going to color it blue. Now to fill in these missing spots, this is where it gets a little trickier. But we have a little shortcut that we always use, which is that what goes up must come down. So if I had grams of sodium up here, I need grams of sodium down here. What goes up must come down. Now, the next thing we have to think about is, okay, each color only gets used twice. I've now used grams yellow twice. Can't use grams again. I gotta switch to something. And I have to look at my little map and ask myself, what can I switch to? Can I go from grams straight to atoms? Can I switch straight to atoms? No, because you have to have moles in the middle. Going from grams to atoms, you have to have moles in the middle. So if I have here used grams twice, I may be trying to get to atoms, but what I'm missing in the middle is moles. So I'm going to go from yellow to green to get moles, and we're still talking about sodium this whole problem. And again, that makes sense. If I try to make yellow and blue touch, I'm going to get green in the middle. If I try to make yellow and blue touch, I'm going to get green in the middle. There's no way around it. So if I'm done with yellow, I have to switch to green. That's the only way I can end up at blue. So my moles are green. And then to fill in this bottom fraction, again, guess what shortcut still works? What goes up must come down. What goes up must come down. So if moles of sodium were on top, then moles of sodium are going to come down. What goes up must come down. Again, no numbers, just words. Just unit and element. Once we have all these fraction spots filled in, we can also recognize that eventually I'm going to get to some answer where grams have been used twice, I'm done with them. Moles have been used twice, I'm going to be done with them. But atoms will have only been used once. So the second place I'm going to use atoms is going to be in my answer. and it's still going to be sodium. And that way each color does get used twice. 2 yellows, 2 greens, 2 blues. 2 grams, 2 moles, 2 atoms. Now to fill in numbers, we can come back up here. Remember moles? Green is always 1 mole. So in these 2 spots where I have green, I'm going to make it 1 mole in both of those spots. Green is always 1 mole. So where I had green, I'm going to write 1 mole. For the grams, it says to use the number from the periodic table. So I've got to go find sodium on the periodic table and find its mass. So take a second, flip to the back of your book, hold your page so you don't lose it, flip to the back of your book, look for sodium. Its mass is right here, 22.99. So that is the number of grams that I am going to put here. Again, when we were filling in numbers, we knew for green, green is always 1 mole, so I put 1 mole in both of those spots. Grams, we use our number from the periodic table, so I went to the periodic table, I found sodium, since this problem's about sodium. I just wrote its mass down, I just copied its mass straight from the periodic table. Then when it's blue, atoms, when it's blue, use 6.02 times 10 to the 23rd. So when it's blue, I use 6.02 times 10 to the 23rd, and I just copy that number in here. From there, all my fractions are filled in now. I'm ready to use my calculator and do math. And just like if there were only 2 fractions, we're still going to multiply straight across. Top times top times top, get a new top. Bottom times bottom times bottom, get a new bottom. And then divide top over bottom. So I'm going to do this times 1, 189.2 times 1 times 6.02 times 10 to the 23rd. Type it in your calculator. Type it in your calculator. 189.2 times 1, which, I mean, you don't really need to type the times 1. You know that's still going to get you 189.2. But definitely that times 6.02 times 10 to the 23rd, you're going to have to type. And when you do, the calculator gives you this over 1 times 22.99 times 1. That's just going to be 22.99. So you're going to divide this number, which you got from doing this times this times this, over 22.99, which you got because the bottom was 1 times 22.99 times 1. Divide those out in your calculator. And when you do, you get 4.95. Remember, we round to the hundredths place. And it says E24, which means times 10 to the 24th. Here. Here you go. Let's try some more. If you have 7.29 times 10 to the 23rd molecules, that's a typo, that should say atoms, of calcium, how many grams of calcium do you have? Well, atoms are blue. Grams are yellow. We don't see the word moles in this problem, but I know between blue and yellow, I have to have, between blue and yellow, I have to have green. I have to have moles, which means I'm going to need 3 fractions. So I can draw 3 fractions, and I know that this number they gave me right here always will be on top of the first fraction, number and unit and element over 1. Number and unit and element over 1, always. I also know whatever they're asking for. They say how many grams of calcium. I know that whatever they're asking for is going to go on top of my last fraction, always. And at this point, you've probably noticed that whatever's on top of the last fraction, that's going to end up being what you label your answer. So if I know grams of calcium are on top of my last fraction, I also know my answer is going to be grams of calcium. Now we just have to figure out what goes in these empty spots in the middle. And I know that what goes up must come down. So if I have atoms of calcium on top, atoms of calcium are going to come down. Remember, not numbers, just words. Just unit, just element comes down. Now, I'm at blue. I'm trying to get to yellow. But if I try to go from blue to yellow, in the middle, I'm always going to have green. Wherever blue tries to touch yellow, there's always going to be green. There's always going to be green, which means next after blue has to be green. Next after blue has to be green. And I know that green is moles. We're still talking about calcium. To fill in the bottom of this last fraction, I'm going to go back to my old standby. What goes up must come down. What goes up must come down. So if I had moles of calcium on top, moles of calcium have to come down to the bottom. Now I'm ready to fill in with numbers. I know that everywhere I have green, everywhere I have moles, it's always going to be 1 mole. So down here where I have some number of moles, it's going to be 1. And down here where I have some number of moles, it's going to be 1. For atoms, when it's blue, you use 6.02. When it's blue, use 6.02. So I'm going to type. I'm going to write 6.02 times 10 to the 23rd right there. And for my golden grams, I use the number from the periodic table. That means I have to go to the periodic table. I have to flip to my periodic table on the back of my book. I have to find calcium. I'll give you a hint. Calcium's right there. And I got to make sure I pick its mass, which is this 40.08 right here. So I just copy that mass, 40.08, from my periodic table into my fraction as a number of grams. Once all my fractions are filled in, again, now it's just time to do the calculator part. Top times top times top. If you type that in your calculator, 7.29 E23 times 40.08 times 1, but I mean you don't really need to type times 1. You get 2.921832 times 10 to the 25th over 1 times 6.02 times 10 to the 23rd times 1, that's just going to be 6.02 times 10 to the 23rd. So when you divide these in your calculator, if you typed it correctly, I got 48.535415528, blah, blah, blah. We don't need all those digits. We round to the hundredths place, which is this part. This 5 over here tells me to round up. So instead of 48.53, I get 48.54. Okay. This one on the bottom, try yourself. I'm going to go ahead and tell you, I'm going to point out that you've got grams, which are yellow. You've got atoms, which are blue. The only way to get between yellow and blue is to have moles in the middle, which means you are going to need 3 fractions. And I'm going to tell you right now, if you do it correctly, your answer should come out to be this, 4.39 times 10 to the 24th atoms of carbon. See if you can fill out these 3 fractions and then check your work in your calculator to get there. I'll point out that when you take a quiz over this and when it's on your test, we do grade the work, not just your final answer. If your work is wrong or incomplete, or if your work is missing labels, if you're writing just numbers and no labels, you're not getting credit. You're getting like a 0. So you have to be able to fill in your fractions correctly with number, unit, element. Every single fraction, number, unit, element. Except for where it's just a 1 on that very first fraction. Everything else, you need number, unit, element, number, unit, element, number, unit, element, number, unit, element, number, unit, element. Or you don't get credit. You get nothing. So make sure you can fill out these 3 fractions. And real quick, let's go to your stamp page. I believe at this point we are now on, let's see, probably the 28th and 29th, depending on if it's an A day or a B day. And you're going to get a stamp for page 21. And Miss Woodlock will tell you otherwise if she wants to change that. So, make sure you can fill in these 3 fractions. If you type it all in your calculator, you should get this. If you don't, or if you have problems filling this out, then you're going to have trouble getting this stamp. And you're going to have a lot of trouble. Oh, wait, hang on a second. Yeah, you're going to have a lot of trouble on your quiz. And I just realized, I said page 21 on your stamp. I meant page 22. I'm sorry. Page 22 is the stamp. Fix it, fix it, fix it. Page 22 is the stamp. Fix it. Okay. Anyway, fill in your 3 fractions. Check yourself. Maybe check with a neighbor, check with Miss Woodlock. Make sure you're getting the right answer over here. And then move on to this page. Remember, you have to show all your work or you don't get credit. And I'm going to pass it over to Miss Woodlock now.